Finally, this is a very last, very simple example of how to handle signaling um, for the processes. So the main routine has a binding between catching the default process signals. So this is a signal handling routine implemented by the kernel, and these are the default constants that we can either leave unchanged. So when we called interrupt by Control C, the process will interrupt and stop effectively. Or we can now say, well, this signal, when received by the process, will be, instead of handled by the kernel as the default action, it will be handled by my handler function that I defined. Also, the signal quit when called on a process, which is control backslash, will be handled by, instead of default, will be handled by routine called my handler. And finally, signal stop STP, which is a little different between signal STP and signal stop. So there is signal stop, which cannot be ignored. So there is no way of overriding it. It's the default kill. Signal STP, as we can see here, could be altered how it's handled, and basically always say do a null op. So basically the way signal stop is handled for this case is by routine signal ignore. So effectively I have disabled the Control Z of my application. So then I will have just an endless loop which will be reading the standard in for the signals. So the bindings here between the signal and the custom routine called my handler, which is implemented here as a my handler routine, which takes the default signal. So we'll just write we are handling a given signal, and the switch will be checking what are we handling. So if we are catching or receiving signal interrupt, then do something. In this case, we'll do nothing other than print out we receive signal interrupt, and then we'll break out of this case loop. If we receive signal quit, well, if we break out, there is no real way of killing the process. So in addition to printing out signal quit, we will also exit, because here we effectively disable both quit and stop signals to the process, so there is no way of killing the process. And if there is some signal that we did not take care of, it will be the default here is unhandled signal. So let's see how this actually works. So if we execute signal, it's stuck in the endless while loop. So if we do Control C, it says I'm entering the signal handling routine, and inside I'm running the switch, and the switch detected interrupt. So instead of Control C effectively interrupting the process, that was overwritten by my user-defined function, my handler, and all I do is print. If I do let's say Control backslash, that's gonna get caught, and it's caught with the signal quit, and as a matter of fact, I'm going to force the exit. To show that I have disabled Control Z, the moment I press Control Z, nothing happens because I told the kernel that signal that is by default handled by signal stop is now handled by the routine signal ignore, so it is a no op. So the only way to kill this is using Control \. If I disable this binding between signal stop and signal ignore, recompile and run, the moment I press Control Z, I effectively killed. So this is interruptible stop. So I killed the process because I did not overwrite the signal stop signal to the process handled by the kernel as the true stop, and I did not overwrite it as ignore. So here is a very simple way how to talk to the processes from the shell and or from the standard in by using the kernel defined signals that processes by default will handle for you.